warm welcome to Mr. Sim Gyo-soon, Director of ACAD System Penang, esteemed speakers, distinguished guests, ladies and gentlemen. Selamat pagi and good morning. On behalf of ACAD System, welcome to CAD Synergy Manufacturing Enhancement through Bridging Design. Thank you all for joining on this lovely Thursday morning, and I see some familiar faces and as well as some new faces. I hope everyone has settled in and enjoy the breakfast that was provided outside. Today, we are gathered to understand the full potential of design to manufacturing workflow with seamless Autodesk solution. In today's agenda, we will have a short introduction and 4 presentations in total by our speakers. In between, we will have a short break for 15 minutes. Then we will have a Q&A session and a lucky draw session. Right after that, you are required to fill in our evaluation form. The evaluation form is to help us improve to serve you better. Finally, we will have a photo session together with everyone, and lunch will be at Mesa 9, Level 2. So for your information, we will also be live on Zoom during the presentation. If you'd like to join through the Zoom, you can scan the QR code to join the meeting. To begin today's session, may I please have the pleasure to invite Mr. Syed Zulkarnain, Solution Consultant Manager of Datek Solution, to deliver an overview of AutoCAD Industrial Specialized Toolset. Please welcome Mr. Syed Zulkarnain.
Hi, good morning, everyone. So I hope everyone. Oh, sorry. Hello. Hello, testing 1, 2, 3. Yeah, more or less the same. All right. So good morning. So my first session today is very quick and easy. So I would like to understand. First of all, before we start anything, so do you use AutoCAD? So which one did you use? Okay. So I don't want to see hands raised, but can you take up your phones and try to scan the QR code if you can? Okay. Is it working?
Ada Zoom link ya?
Is it working?
Zoom link. Oh,
okay tak?
sorry.
Okay. So
Station.
so it will show live the effects, the result. So far only 4% or 5%. Okay. See, oh. Okay. I actually want to see this. 10%. How many have registered this morning? 20. 20. Right. See if we can get anywhere near 20. Okay. Interesting. Almost half, more than half is using AutoCAD full versions. Okay. All right. So maybe again to the next questions. Second questions. So early morning, I already asked too many questions. Okay. Second one. So it will change in your screen. To the next question. In your own words. Since more than 60% is using AutoCAD full versions, let's see if you're aware of what is industry specialized toolset. Okay, you see any words coming out? Okay, see people typing, right? No idea. All right, so cool. At least we know. So at least we can play some Okay. No, I am not aware of this. Build and design. Okay. Interesting. Special application customized for industrial users. This one looks like Google may answer. It's okay, you can Google if you're not sure what is it. Not judging, so custom parts. Okay, no, okay. Okay. See, maybe we wait for maybe another 15 seconds. Is 4 more people is typing. Not aware, okay, not aware. Some parts. Okay. I still got people typing. Let me see. Sometimes the internet a bit. Okay. For mechanical engineering. Okay. Computer aided design. That is CAD. Okay, I'm not sure about. Okay, please explain, I believe. All right. So, and next questions. Okay, this is just for me to know who is in front of me. Okay, so at least I can tweak whatever I'm going to say later. Okay, so I've seen the registration list, okay, with company names, but just to see what kind of products that you are producing, I mean, your company is producing, or what kind of drawing are you doing? It could be oil and gas, engineering, M&E, process plant, water treatment plants, just to see. Okay. Machines maker, automations, okay, water treatment system, material handling system, okay, okay, automations, constructions, rack storage, or I should do like wood cloud, but it's okay. Electrical selling brick making machine, okay. Semicon, material handlings, okay. All right, so we have a variety of industries or products here. See, one people stay typing. Let's see. Tooling companies, okay. Custom tool die, okay. Now, let me just go to my session today. Okay. So, sharing. The screen. Need to on other.
Boleh lah.
Okay. Testing 1, 2, 3. Go. Okay, sorry, got a bit of echo. So, a quick session. drawings. So in case some company, they are mixed in between these two worlds, constructions and manufacturing. Okay, sometimes they need to create floor plan to put their machines lah and so on. Okay, so it's good to have the IST because you have access to the so-called architectures, and also you can access to the mechanical things for your factory. So example, this is in architecture tool sets. Okay, architecture tool set here, you can see on top here is wall, doors, roof, slab, stairs, and you see all the libraries here. Okay, this is AutoCAD, yeah. Okay, you see the sizes of the door all can be arranged, changed. You see list of libraries. Let's say you just want to put windows. Okay, put windows there inside. Okay, this is just like 2D, like you draw your 2D, but instead of putting in rectangles and all, you're putting in libraries, component. All this is parametric where you can change the size. Okay. So let's say I add some maybe internal wall. Okay, this one external wall and then it's internal wall. The one is a bit thinner. Okay, you see there's auto trimming. Okay, you see when I add this door auto, it will be trimmed automatically. Okay, of course this one I fasten now. Okay, and then put in some maybe libraries. Let's say you're doing interior or you would want to add some more details. You can also put in all these libraries, all these so-called catalog. They are online catalogs where you can browse for some samples. Okay, things like example, this is you are building a toilet example. So all this is available in the catalog, and from this 2D, it's automatically converted into 3D. So basically, when you're doing that 2D, it's automatically converted into 3D. Just for floor plan. I don't go too detail on construction and building or what. Just a simple floor plan. You can also get this. So you can put your machines in. So whatever things that related to your company in case you need a floor plan. Okay. So like also MEP, mechanical, electrical, and plumbing tool sets. So things like, okay. So earlier I showed how to create the walls and everything, right? Okay. Also comes with this AutoCAD full version is the MEP part of it. You see all this is also one part of the AutoCAD IST. So you can see ducting and everything here. Okay. Okay, mechanical tool sets. So mechanical tool sets. Okay, now you get the concept of what is AutoCAD industry specialized tool set, right? Roughly sudah paham a bit, right? All the features, functions, more to the industry. Okay, so like mechanical can help you to create all these so-called, if you're into GD&T, okay, dimensionings and all, this is more detailed than the normal AutoCAD LT. Standard libraries like bolt, screw, nuts is also available. You tak perlu draw, everything is there. Okay, a simple calculations of load can be done, but it's in 2D. And automatically creation of bill of material. If you use AutoCAD mechanical, one part they will track lah. Every part you put in, they will track. So later you boleh extract all the bill of materials or part list. You tak perlu calculate manually. This is all, but AutoCAD mechanicals only have 2D lah. Okay. So here is how it looks like. Okay, you can see atas ni, ni nampak a bit similar, but they actually have things like contents, okay, annotations, different. So let's say we go to view, sini ada the mechanical browser, like mechanical drawings. This is more like 2D, tapi mechanical drawing sometimes ada multiple drawings yang inside kan, reference. Okay, they have their own browsers. So this one like they can track like upper parts, upper assembly you put in. Okay, just for managements. And then you nampak sini ada more detail like construction lines. Okay, like height situations ni macam automatically creation of, you tahu ada drawings yang mechanical drawing yang front and back. Yeah, so the back can become hidden line kan. Okay, so AutoCAD mechanical will help you to automate that. So you just tell mana satu depan, mana satu belakang, so they will automatically create the hidden lines. Let's say you move the two profile around kan, dia akan automatically update juga. Okay, electrical tool set, same concept, but you have all this. So libraries, okay, so 65,000, maybe more electrical symbol. So later, Nabil will show more details. Okay, automatically wired component text and wire text, yang ni. Okay, and then automatic report. Okay, and then Plan 3D, Nabil will cover Plan 3D kan? So Plan 3D and also PNID. So if you are doing plan or process or pipings, okay, so you maybe you ada buat schematics drawings. So AutoCAD juga ada schematics drawings where you nampak here is all schematics related, and then all the libraries pun sudah ada, pumps, compressors, semua sudah ada. This is Plan 3D. Okay, so if you have AutoCAD full versions, you have this. Okay, just you tahu atau you tak tahu saja. Okay, okay, generations of ISO drawings. Okay, and then this is one yang where in the list of AutoCAD toolset, right, ada 7 kan. This one yang paling kurang famous. Paling kurang famous nowadays lah. Okay, because dia bukannya create drawings, but they actually restore drawings. So macam let's say kan ada old, very old paper drawings yang sudah rosak, kan? Yang macam kalau pernah tengok drawing lama yang dah kuning-kuning, the ink pun dah pecah-pecah, right? So one way is we redraw everything. Okay, usually bagi tahu intern, redraw. Give to intern, okay, redraw. I see some people laughing and you see you buat ni. Okay, so or maybe macam restorations, drawings. Okay, so this kind of, let's say example, this is very old drawings. You nampak the quality is very bad. Okay, this is from paper drawing, physical drawings. So you scan the physical drawings, okay, and then you bring into AutoCAD to clean up and restore. Dia tak boleh automatically convert because it's not PDF from AutoCAD. You know AutoCAD can save to PDF kan? This is not, this is from paper. You scan the paper, you tak boleh automatically convert. Right? Okay, so, and then plus the conditions are very bad. So you need to restore. Depending on conditions, sometimes maybe even faster kalau we redraw. Depending on condition and what type of drawings lah. So maybe, let's say you nak restorations of very old building, maybe historic buildings. Memang tak ada AutoCAD drawings kan, or paper drawing, so you need to restore lah. So example macam this drawing nampak dah very bad, then clean up become like this. Okay, a quick of intro. This is from a scan drawings. Okay, a paper scan drawings. So raster design is only help you to macam detect all the endpoints. Okay, it detects the lines untuk kita senang to, what you call it, to redraw back lah. Okay, sometimes we can automatically convert. There are options to convert juga. Okay, we can convert the line automatically, and text we can convert the text automatically to AutoCAD text. Okay, some lines we can convert depending on the punya quality. Some we need to redraw. Okay, like in this case, we redraw lah. But we also have things like automatically convert. Okay. So what this video is showing is one by one lah. Okay. So that is raster. So total we have 7 tool sets. Okay. So when you, let's say you nak download and install AutoCAD, you have these 7. If you have AutoCAD full versions lah, or AutoCAD industry specialized toolset. If you have LT, you tak nampak all this lah. Okay. Okay, let me just next. So the AutoCAD portfolio, really quick. So with AutoCAD IST, you have all the tadi 7. specialized tool sets, collaboration tool, cloud connections, AutoCAD mobile and AutoCAD web also available across with LT juga. So how to use AutoCAD mobile and AutoCAD web? In case you want to know more, maybe we can talk separately later, because I already passed my time. Okay, so this is supposed to be a very quick overview only. Okay. In case you want to know more, we talk separately. Okay. Questions? All good? Still okay? Yes. Hand-drawn. Okay. So hand-drawn, kalau let's say you guna raster, so that hand-drawn you can scan as PNG. And okay, so some of the tengok condition lain lah kalau baru. Sepatutnya you boleh, dia bukan auto convert everything, but they can macam the whole loop ke, you kena select which to convert. You tak boleh macam select everything convert. Iaitu kalau let's say the PDF yang created with AutoCAD. So let's say hand drawn on paper, you draw on paper now, and then you sama ada for untuk guna raster, you kena scan it as image PNG. Best format is PNG. Okay, so that image dia akan something macam you nampak tadi, like an image first, but it's more towards macam we need to edit the macam photo editor, kita kena clear the backgrounds, make sure the lines pop, and then only kita trace ataupun convert it lah. You just have to draw. So they just convert whatever you draw. Bukan auto. Raster bukan auto. Raster is for restorations. Yes, you can trace. So kalau auto convert tu is from PDF. AutoCAD PDF automatically convert into AutoCAD. So that is different. This is for very old drawing, macam paper drawings, or maybe like you say hand drawn on paper kan? Yes.
All right, so welcome back, everyone. So for this session here, I'm just going to continue with the AutoCAD industry to set, and we would like to connect this with Inventor, right? So one of those examples here is that, let's say if I use Plant 3D, right, and then I would like to merge with Inventor, right? So the first topic here will be the leveraging Inventor models into AutoCAD Plant 3D. Basically, if you have a 3D modeling that create from Inventor, and then you can push it inside AutoCAD Plant 3D. Right? So I believe Seth already show you about the instructions to set. So this is one example. So when you purchase the AutoCAD, the full one, right, so you will get all of these specialized to set, and one of those that I will share here is the Plant 3D to set. So why Plant 3D? Right. So I believe Seth also show here. Right. So by all means, Plant 3D or piping design, you can actually create using the normal AutoCAD. Right. So in the normal AutoCAD or the full version of AutoCAD, you can also do 3D modeling. Right. So you have the 2D that you can create schematic designs and so on. But if you use the Plant 3D, so this one will speed up the process of your creation for the piping and so on. Right? So one of those is that you have increment of 50% faster to create and modify, because most of the time there are tools or there are parts that are already provided, right, that you can basically use. Right? And you can also generate report 66% faster, because the item that included inside of Plant 3D, so not just a model, so you have the information that you can fill in that later on can be explored out. Right? So basically, this is the examples. So you have the 74% of productivity gains. So for example, if you use AutoCAD to design the piping, the piping 3D model, right? So for example, it take about 100 hour, 1,000 hour. So in Plant 3D, so this one reduced to 260 hours. Okay, so why does it save? So this is just an example. So first of all, we have the creation and modification of PNID, which is for schematic 2D for the idea. Right? So by using this, you have a decrease up to 42% of time. Right? So when you create using the PNID, so you can actually create normal by using normal AutoCAD to create these pipelines and so on. But for the Plant 3D here, they already provide the tools that you can just input here, right? So you don't have to create a sketch, right? So you just fit in the icon inside, and then you can just use the line here to indicate which piping connect to which area, right? And it will automatically do the process. You can create the tag inside of the line, so the lines and the tools here has informations that that you can input here. So that is the first one. Second one is the creation and modification of piping equipment and structures. So this one is increment about 50%. So again, you can create the 3D model, but from here, same with the PNID, where you can actually click and drop only the part, right? And the piping also easy to create. So you can just connect from one point to another point. And if you have the equipment already include inside, so you can just click at the nozzle point here. So automatically it will create the lines here. So if you want to do some editings, this one also very quickly to use. So you can just pick one point here, move to the other, and automatically the pipeline will be fixed and it will fill on the interior, right? Next one, we have the engineering data management. So this one about 76% increment. Like I mentioned before, we have the informations or data inside. And not only that, so if you create the schematic one, right, from PNID for 2D, for the idea, basically, then you want to make it into 3D. So from the 3D piping, you can actually bring out the information that you have before. So we have the list of item that has been input for the schematic one, right? And then you can just drag and drop into the 3D, right? So with this, you have the information and the report can be created much more easily. And then over here, we have the piping isometric drawing. So for example, the 3D piping that we create before, so you can also convert it back into 2D, right? So for example, the pipeline, right? So if you want to generate pipelines, usually very difficult to use PNID because that one is only for the ID only, right? For the isometric, right? So you can generate from the 3D before, and you can exclude the information that you want, right? So for example, able to find the pipelines, and if you have the pipeline with different segments, that you're able to export, and you also able to generate the BOM list quickly, right? So that is for piping isometrics. So we have the same one with the 2D piping, right? So this one for orthographic one, right? Basically isometric, and this one is orthographic. So you can also generate the BOM list for this. Yes, and of course, for Plant 3D and PNID also come with the piping specification and also catalog management, where you already have, right? So Autodesk already provide the pipe, the tools, and so on. You can just pick from here. And if you want to, we have the spec editor that you can add your own equipment, right? You can create your own equipment. Then later on, this one can be used directly inside of AutoCAD Plant 3D. Right, so pirate with Inventor. So what Inventor? So Plant 3D can do 3D modeling. Some of these equipment already been provided, but Inventor can do much more detailed design, and it's much more quickly and easier to create. Right, so one of those examples that you can use with Inventor is that one is the powerful 3D modeling design, so it's very flexible. Anything that you create, you have the history of what you have created before, right? So if you do sketching, you do some editing, so you have the history list that you can go back and then you can modify later on. So that is something that AutoCAD cannot do, right? The next one is the assembly level engineering tools. Basically, inside of AutoCAD, usually you design one parts for all of the parts will be combined together. Where inside of Inventor, you design parts separately, right? So maybe part 1, part 2, part 3, and then you can combine them into one single file. It will become one project, right? And again, it can also generate the 2D drawing, but this one we can just leave it to Plan 3D. Right, so another example why using Inventor. So one of the things is that Inventor is a complete design solutions, right? It comes with content center file here. So if you take a look here, we have bolts, screw, nuts, beam members, everything already been provided by Autodesk. And if you have your own parts, your own library that you need to input, you can also do a custom that you can add inside the content center file. And the next one is we have the frame design. So Plan 3D also have something similar with the frame design. It's more on structure, but in Inventor, it's much more flexible. You can edit easily, right? So, and it's also allow you to trace which of the beam member that you have included over here. And lastly is the tube and pipe. Right? Again, you can also do tube and pipe for the Plan 3D, but for Inventor, sometimes when you design an equipment, then that particular equipment need to have a tube and pipe. So instead of doing that inside Plan 3D, you can do it early on with Inventor. So this one is just an honorable mention. So if you want to do a well-designed, so Inventor also provide that. We have the sheet metals and also cable and harness also, but this one is basically more on electrical one. Right, so to combine them together, we have the beam interoperability inside of Inventor, where this one allows Inventor to take their models and you can compress it and transfer to different software. And what it does, that it allows you to add some information inside, right, such as the auto beam object, and then you can configure so that it's able to fit inside nicely on other software. And not only that, you can also input some configuration so that when you add this software, this model into other software like Plan 3D, for example, Plan 3D able to know which are the pipe locations, right, or which are the ducting or the electrical connections. So that is some of the things that beam interoperability can do. Right, so right now I'm just showing you what are examples. For example, if you take a look here, we have a very complex models from Inventor. So if you try to do the modeling, do this modeling inside of AutoCAD, so this one can be very, very difficult and very hard to create. Right? But from the Inventor, you already have all the tools required, so you just need to create and pick and drop. Right? But if I want to, so if I would like to bring everything here into Plan 3D, so this one can be very difficult because we have so many parts here. For example, if you take a look here, we have small part, bolt, screw, nuts, all the electrical wirings, all the pneumatics. So most likely you don't want to bring everything. Okay, so if you take a look here, this is also an assembly file. All of the file can be traced separately, okay, because it's a separate part files. So instead of sending all into Plan 3D, we can actually simplify the entire project first. Right, so Inventor allows you to simplify the object very quickly, very easily. So there are buttons here that allow you to simplify this particular object. So you just need to select what are the criteria that you want this to reduce. For example, here, let's say everything I would like to convert it into blocks, or maybe each of the part will be a separate block. So that is some of the things that you can configure. Maybe I don't want that. I just want to remove some of these small part. So if you take a look, we have some railings, some bolt screw nuts, very, very small part. You can filter out easily by using this exclude part by size. So you just need to include what are the size that you want to reduce. For example, 18 inch. So Inventor will find all the item here less than 10" in size, and it will remove completely. So you don't have to select everything one by one. Okay, but you also have the ability to select manually, right? So I can just select some of the tools that I don't want to bring. Okay, so if I find some mistakes, I can also undo that, so I can find and trace back what are the items that I haven't been excluded, right? So, and then I can also bring it back. Okay, so that is the remove parts. For example, let's say if I would like to make it much more simple, I would like to remove a features. For example, if we have hole, pillars, right? So this one, Inventor allow you to detect which are the area that have hole, which are the area that have pillars, and you can basically suppress it, and it will become much more simpler. Right? Okay, but for this case, I basically just simplify everything. But you can also preserve some of the area that you want to keep, right? So you can just select, right? Okay, so let me just skip for this part here. So the output here, I can just specify whether I want these to be as separate parts, or I would like to make it everything is combined together into one solid object. But you can also do something like that. But once I'm done, now the project is now easily to be sent. Then I can just go and use the beam, right? The beam interpretability that already have inside of Inventor. Okay, so let me just skip this part here. Okay, so over here we have the beam. Right? So if you take a look here, we have the MEP connections, allow you to select which of the equipment or the parts that have certain criteria here. For example, here I need to have a piping, so I need to tell that this model has piping. So later on, when I bring it inside of Plan 3D, Plan 3D able to detect, so they are piping over here, and I can easily create the pipe connection from. Okay, so from here I can just input some information, maybe what type of this piping is for, right? Okay, so what are the connection types, and so on. Okay, but for this is basically just a repetitive. Let me just skip for this part here. Basically, I'm doing the same thing. Okay, so other things you can also configure the building components. So, for example, if I want to bring it inside other software, right, except Plan 3D, so I want to make sure that what I see here is exactly what I see inside of 3D. So, for example, if you just bring it, sometimes the orientation can be flipped, right? The angle is not correct. So this is where you can configure first, so that when it includes inside of Plan 3D, this is exactly how you get. And this one just you can also input the product classifications. And you can also include other type of properties, maybe model properties, for example, but for Plan 3D, this one might not be needed. So I can also include descriptions. So this one can be seen when I add it inside Plan 3D. Right, so everything is done. So I can just exclude this component. I can export this building component here. And not only that, once you export, it will tell you the information that you have added before. So it will automatically create report for you. So that maybe this is not the same person that use Plan 3D. So when I send it to other people that use Plan 3D, I can also tell them what are the information that I have added for this component here. Right, so you can see the report has been generated automatically. So this is the list of information. So the next person that receives this, so they know what that you have actually done for the component. Okay, so the reason why we want to simplify first. So first of all, you can protect your component, right? You can protect your designs, and the other thing is that you can make the project lighter so that it can easily be managed on other software. Right, so from the plant itself, so you can see we have some piping, some components, some equipment. So this one can be added easily by using this list to palette here. We have the piping creation. You can just pick and you can just draw the line here. So automatically it will create a part. The connection is also very easy, but for now, let's say if I would like to bring back the inventor files, so I can just bring from the inventor equipment right here. There you can see that I'm able to add the component just the way that I see from the inventor. Okay, so if I take a look here, so it will tells me the description of this item, right? So we have this water separator here that has been added from the inventor. And if I take a look at the piping locations that I created before, so automatically Plant 3D able to detect, so there are nozzle that you can create from this area, right? So this is for the piping. Right, so the piping can be created automatically by using the BIM. Right? Okay, so this one is just for connection between Plant 3D and Inventor. So any questions so far about this session here? So any question about Plant 3D or maybe Inventor? Right, so I believe no questions so far. We can proceed to the next part. So before we already take a look at the Plant 3D, so now we take a look at the electrical sides. Now what we want to do here is that we want to connect from electrical, AutoCAD electrical 2D into 3D design of mechanical with Inventor 3D. Right, so we want to connect these two. Same goes, this one is also electrical, which is part of AutoCAD specialized toolsets. Right, so again, why using electrical toolsets instead of AutoCAD? So you will have a very high productivity by using the electrical toolset. Okay, so most of the time, people that use AutoCAD, people that designs schematic design for electricals, they will like to just bring the items and put the icon there instead of redraw back from the beginning. So when using the electrical toolset, there are less that you need to create a sketch. Just need to create a icon and then you can just put inside. All right, so for that we have an 84% faster in creating new design because everything has been included, all of the parts, all the icon, GIC, and so on. So it's already been provided. So we have the library there. Right, so you can also edit design very quickly. And this is basically the productivity gain. So around 95%. So instead of create everything from scratch, you just need to pick and drop and you have the electrical design there. Right, so how does electrical to set save? First of all, we have the comprehensive symbol library. Right, so the symbol already been provided. If you have your own symbol, you can also create and then you can add inside of this library here. And you can see here we have the JIC. You can also select between different type of symbol library, maybe NFPA, JS, and so on. So that one is already provided. Right, so we have the automatic wiring numbering and tagging. So most of the time when you create electrical, you just need to put, let's say for example, I have this ladder here for wires. And the tools here, I just need to pick from the symbol library and I can just pick and drop. And then it's allow you to include some informations. And once the information has been added, the tagging automatically create. Right, so for example, here we have the CR component here. It's also telling you which is the wire number, right, based on this component item, for example. So with this, we also have the electrical specific drafting features, right? So most of the time when using electrical toolsets, you will less likely to rely on the regular version of AutoCAD Sketch because electrical, we have their own intelligent properties inside, right? So you can basically modify the tools that you have quickly. And we also have the automatic PLC drawing creations from spreadsheet. Basically means that if you have data that create from Excel files, you can just bring it inside of electricals and it will generate this design of PLC automatically, right? So you can also export out if you want to. And lastly, we have the tracking electrical drawing change. Now, when using the electricals, usually you come with the, you can create a project, and that project can consist of many type of drawing, let's say drawing 1, drawing 2, drawing 3. And this type of drawing can be interconnected, right, between each other. And some of the tools here, some of the symbols, maybe they have on drawing 1, maybe they have the same symbol on drawing 2, and this type of symbol is connected. So you can track easily by using AutoCAD Electrical. Right? So for example, here, if I have this component here, so I can trace what the component here is available from. So I can see, so it's also available on different sheet or maybe the same sheet. Right? So we have list of the data here. Right, so connected with Inventor, right? So what Inventor? So Inventor also come with cable and harness. So you can do electrical design from the AutoCAD. You can also do electrical design from the Inventor, where the 2D drafting is where you create from the AutoCAD Electrical for schematics, for the ideas, and to make it a reality is where you use Inventor. So this one can work separately, actually. But once you work separately, sometimes you want to merge or sync these two information together, right? So later on, we can connect by using electromechanical, right? So what Inventor can do, so it can create cable and harness, right? Because cable and harness comes with library of wires that you can just use. We have the automatic routes, right? So for example, when you connect from one point to another point to create wire, so you can have a very messy designs, and this is where you can tidy up by using the automate route so that it's allow the wiring to follow a certain segment that you want it to go, right? And then we have the neighbor environment. So if you use electrical before, usually what people do in the past is that they want to measure the line length. So they will take the entire wire segments and then they'll put it into a board and they will basically measure from that, right? Okay, so this one is just a harness library. Then we have the automatic routes, for example, here. Okay, so allow me to connect from one point to another point, and it will follow the route here. And for the neighbor here, basically, I can do that the same with Inventor, right? So just put all of the wire here, and I'm able to specify where are these the length here, right? For example. Now, electromechanical. So this is the tools that allow you to sync, right? So it's available inside of AutoCAD, it's available also inside of Inventor. So what it does that it's allowing you to link two of the same components, right? Maybe one you create schematic only on electricals, and the other one same component, but on 3D, right? Inventor. So you want to have a link between these two. So you can use the electrical mechanical. Right? So road cable is basically the Inventor 3D, and then schematic is basically AutoCAD electrical. Basically, you want to combine, you want to merge these two. Okay, so now is one examples on using both electrical and also both electrical AutoCAD and also mechanical Inventor. So for example, here I have the mechanical parts, and what I would like to do is that I would like to bring some electrical components. So you can actually find from the AutoCAD electrical libraries or the catalog browser, right? Right? So this one is basically from the AutoCAD electrical browser, and I can search what type of manufacturer, right? For example, Allen battery. So I can just click and I can just drop these items. Right, so if you don't have the model yet, you can also create your own model and then you can add from the library. Right? But for this time, it's just basically for assembly. So let me just skip this part. Right, so next one is where I can go to the top here. So we have the electromechanical link setup. So what I do here is that I can create a data link that can be read inside of AutoCAD. Okay, so for example, let me just skip this part here. So for example, I save it on the document. And once I'm done, I'm able to see a library of list, the item that I have synced. Okay, so if you take a look here, we have the location view. So this is basically the electromechanical parts. If you take a look here, we have the inventor parts. So it's able to tell you the list of what part is actually from inventor or maybe from AutoCAD. So I don't have AutoCAD file yet. Okay, but what I can do is that I can fill in the information so that it will have an electrical properties inside. Okay, so let me just put this part here. This one is basically just I can fill in the information, so I can just trace back from the catalog, and automatically it will select the information about the catalog. So now what I do here is that I just save the link, save the sync. So if I go back to the electrical one will have the same tools. If you click here, this is the same tools that we have before inside of Inventor. We have the electromechanical link. Okay, so I can create a new one from here, but for this case, we already create from the Inventor. So for the electromechanical here is basically work two ways. So either you start from AutoCAD or you can start with Inventor first. So either way. So this one I can just pick the data that I have from the Inventor, and you should have the same location that you see from here. So we have the parts from Inventor from AutoCAD. So if you see here, we have the symbol here, which is the Inventor part. We also have the symbol here for electrical part. Right. So this is the new part from the Inventor that we just add, which is the motor starter here. So I can also add a new component from the AutoCAD electricals, and I can also bring it back to Inventor by using this sync here. Okay, so this one is basically just put the motor starter inside for electrical, just to have a link between these two. So for example, if we have motor starter here, this is Inventor. But once I put it inside of electrical, then you will see the link between these two. So now electrical, AutoCAD, and mechanical is now synced together. So this is what basically one part item. Right, so I can do the same. So I add a new part from AutoCAD electricals, and I can go back into Inventor. Okay, so let me just skip this part here. Okay, so if you take a look here, this is basically what you do inside of electrical. So you put an icon here, and this will be the list of information that you can input here. So normally, if you try to do it using normal AutoCAD, you do have something like this, but you need to create manually. That one's what we call as attribute, right? So you need to create everything. But for electrical, it's already provided. You just need to put restrictions, catalog data. So this list is already available. Okay, so the part has been included over here, so I can just go back to Inventor. Let me just skip it. So for Inventor here, I can sync, and now I'm able to see not only the Inventor and not only the sync part, I'm also able to see the electrical part now, right? The one that we synced before, right? So we have two symbols here. This one is symbol for electricals, and then we have a symbol for the Inventor part. Okay, so if I want to, so I can also bring electrical parts inside of Inventor, just like we did with the electrical from Inventor part. Okay, this one is basically just connecting. Let me just skip this part. Right, so we do have the electrical part here as well, but it's not actually connected one part. So if you take a look here, we have the same item, PJ7 over here. We also have the PJ7 for the Inventor. Right, so we have PJ6 from the AutoCAD symbol. We have PJ6 for the mechanical as well. So what we can do is that we can actually link together between these two. For example, this electrical part here. So I want to tell inside of Inventor, this is the part that I want to link with the Inventor part. Right, so we have two PJ7s. So I want to make sure tells that both of this is actually a one item. So now you see that we can actually link them together. So I can do the same with the electrical part. So this one I create from the inventor. So I can go back to electricals because maybe I don't find that components inside of mechanical. So I can find that from electrical as well. Right, so I can find the inventor parts, then I can link with the AutoCAD symbol here. So that is just linking between these two. But if you take a look here, we still have some exclamation marks, which indicate there are still something that not yet complete, right? So the electrical mechanical also allow you to trace whether if you have finished the design or not. So anything that you haven't finished, so it will basically show you based on this icon here, right? So one example here that I haven't done here is that we have the wire connector inside of AutoCAD electricals, but we actually did not have yet this connector inside of inventor. But this is something that we can actually do easily. So let me just skip to inventor again. So inventor, so if you see here for the sinks, everything is synced together, connected. Now I just need to bring the informations about the wire connections from the AutoCAD. So not only that, the single type of parts here also have a pin which allow you to connect wires to wires. So there are pin data inside. As long as the same with the inventor and also electrical parts, it's allow you to quickly create connections automatically. So what happened here is that, okay, so what happened here is that you can create this one manually, but this one I can just find the data from the AutoCAD, and inventor allow you to route automatically between these two points. Basically, this is data that they actually read from AutoCAD electrical, right? And then they just do it automatically for you. You can also do that the same with the electrical part. For example, if I create new wires inside, okay, then I can also bring inside AutoCAD electrical. Okay, so if you take a look here, so the wiring is quite messy inside of inventor, but we can create wire segments, allow you to tidy up the wiring inside of this equipment here. Right, so for example here, we have create the wire segment. There's blue color here. This one is not just not a wire, but a segment to ensure that the wire will be follow inside the segment. And this one can be done automatically. You just need to select the automate routes, and the wire will intelligently find the closest segment that it can follow, and automatically go inside. But actually, I did not select this one manually. This one is automatic. We just put on the closest one. Right, so this is just example from inventor. Okay, so if I want to create new wire, I can also do that. So from inventor also provided, so you can create electrical design directly from inventor without relying on AutoCAD electrical as well. Okay, so for example, I create this new wire here, and I can bring back this information inside AutoCAD electrical. Okay, so let me just move forward for the electrical part. Okay, so this one, I still have some error message here. So I can use this detail or connection just to see what are the things that I'm missing. So you can trace back your the error message easily from here. Okay, so let me just go back to AutoCAD electricals. So same again. So I can do the automatic wirings inside. Same that I do before inside of inventor. So wiring, and you can see the wire is created automatically. And another things that you can do from here is that you can also bring data from inventor. So inside of AutoCAD electrical, where you design a schematic, usually you don't know what are the actual length of the wire, because you just need to make sure what point connect to what points, just basically an idea only. The inventor is where you make it a reality, where you can see the wire length, where you can see where the wire go, right? But you can, once you sync, you're able to see the wire length from the AutoCAD electrical as well. Right? For example, I need to bring how many the length from the inventor. Okay, so now I'm able to see the wire length. So this is the information data from inventor. So that is basically about the electrical mechanical designs. So far, is there any questions that you'd like to ask about these two sessions here? So any questions regarding the industrial sets with connected with inventor? Right, so I believe no questions so far. If not, then we can proceed to the next session. Huh? Okay.
Thank you, Mr. Nabil, for the sharing. I hope everyone finds it insightful and practical with your work life. Now, for our last session, I once again welcome Mr. Sheikh Zulkarnain to the floor. Please welcome Mr. Sheikh.
Okay, so hello, me again. So again, so my session will always start with a QR code again. Okay, so to see the audience, so how many of you are using Inventor for your 3D design? %, yes. Only three people so far. Okay, anyone else? Okay, not yet, not yet, not yet. Okay, let's see. Okay, 11. All right. So, oh, no, yeah, it's increasing. Okay, it's like a race. Okay, and then to the next questions. Okay, so anyone heard of BIM before? Not BEAM, but BIM. BIM, Revit. So let's see. Building. Yes. Basically, the answer is yes. It's the 3 questions. Yes or no? Or everyone is yes. Yes, yes, yes. Okay. Okay, all right. Now let me go to screen. Hello, testing 1, 2, 3. Okay. Hello. Okay. All right. All right. Okay. So since almost half, or maybe all is using inventor or no inventor? And I can see everyone answer yes to what is BIM. So I assume at least you know what is BIM. Okay, so my session is more towards bridging the design from mechanical components or mechanical products to BIM industry, building information modeling or constructions, where if you're aware, so our construction industry is moving towards industrialized constructions, where we are moving from traditional constructions where we go there and build, instead of we build it in a factory and send it out. Okay, so a lot of manufacturers are actually part of construction where they supply their building product like HVACs, aircons. Okay, all that is considered one part of building equipments. Okay. Next. Okay, so we're talking about BIM interoperability and BIM content in these sessions. Okay, so I'm not going to show you how to create how to use Revit or what, but instead of from your 3D models, we're going to make it a BIM content where you can submit or you can send over your products, your components, or your products or your equipments to the customer. So a lot of projects now, they requested their so-called supplier send over BIM format. Okay, so where example you are building a HVAC system, you need to make sure your 3D model, your HVAC system is in BIM format before you send over to them. Okay, it's part of the requirement now. Okay, BIM content. Okay, so what manufacturer customer may think about BIM? So usually, or previously, manufacturer think is something that they do not need. Enough to do, but they do not need. Okay, it's somehow a 3D model. Okay, a tool for architect only, so not manufacturer. Just cost me or manufacturer time and money, or maybe something mysterious. So I saw everyone's answer yes. I assume everyone know what is BIM. Okay, so what is the manufacturing component in BIM? Okay, so things like building equipment or building products. Okay, elevator, lift, HVAC system. This is also considered a building products. This is all designed and manufactured in a factory and installed in a building. So you may think, or you may wonder how actually your products or your equipments relate to building. Just think of it like Lego. Your product need to be fit inside a building. Okay, and then you need to make it fit to make sure it's not clashing with any beam, any doors, or any other building equipments. Custom fabrications, like all this is all manufactured. There are companies who manufacture this. Okay, all the custom facade, okay, building equipment and layouts, all this steel, okay, inside a building or inside a factory with all these equipments, machineries. Okay, modular constructions. This is also now a trend where people are building a whole set like a Lego and just put there. Okay, and then AEC engineering, all this, like example, you can see all these things, and then all the piping inside the buildings. Okay, like waste management system of a building, like where you throw rubbish, where the rubbish will go. Okay, and then inside a building also have things like all the flow of aircon cooling. So like now the aircon is here. Did it reach your side over there? Is it cold your side? So this is all considered as one part of manufacturing as well. Whoever supply the aircon need to make sure that this aircon is cool enough to cover the whole room. Right? So should it be placed here, placed there, or where is the most optimized locations? Okay. Okay, so a bit more detail into a more clear example. Things like in a building, you have curtain walls. So all this is manufactured, right? Still structured. So there are companies who design, of course, architect designs structured, but it need to be manufactured and fabricated. Right? So like custom architecture component, roof, staircase, doors, okay, custom doors, Like all the doors here, you see, this is all manufactured. Toilet, okay, prefab. Okay, this is all manufactured. Okay, prefabrication and productization, things like, okay, so now you seen earlier is prefabrications. This is a product. I mean, people are actually selling this as one product. So this is a whole product, a whole set for maybe 5-story buildings to cover the range of power and cooling and so on. If we go a bit more into details, so you can be under building materials or building products or building equipments or even custom fabrications. So anyone in this field? At least touch a little bit here and there. Okay. Industrial machinery, so all your machines inside a building or a factory. Okay, so now we go into Inventor. So, do you know Inventor can open a lot of file formats? No, not sure. So if you use Inventor, you probably click open before and see a lot of file types. Okay, what is the differences between Inventor and also other products? Other products also can open many file types. But Inventor have the technology called CAD, where it can open all these file format and maintain the associativity of that file format. So example, Nabil is modeling something or this equipment with SolidWorks or other third-party software. So I use Inventor to open this. Okay, so in the meantime, let's say Nabil is working on this component or this equipment, updating something. Once he save, me who open this equipment in Inventor will also get an update. Okay, so that's an easy way to explain it. So Inventor maintain the associativity. It's not converting, it's open and maintain the associativity. So if let's say you half your team is using any applications in the list and another half is using Inventor, you can actually work together. Okay, so that is the interoperability. But in this session today, we'll more focus on Revit. Okay, on how to send your models or your products or your equipments to Revit. Okay, so you already have your equipments in any of this file format. You can use Inventor to open and so-called convert or send it over as a Revit. So you use Inventor as a medium to make it a BIM format. Okay, so it can come in both ways. So example, okay, so example, I provide a lift to this building, to this hotel, right? First, the architect will probably create the building model, right? And then I need to fit in my lift, right? So I need the building models to place my equipment, correct? If I just hantam bagi my lift, you fit yourself, that will not work. Okay, so you need to receive, I need to receive the building model so I can fit in my equipment. So Revit can send over the files and Inventor can open it up automatically, directly. Okay, and then let's say after we open up the Revit and then we want to put in our equipments, we will not send everything. So Nabil explained, you simplify, right? So before you send over or make it a Revit format, you need to simplify so that the file become lighter. Okay, because the architect or the Revit modeler do not need a very detailed model. Okay, they do not need to know how many screws in the equipment, how many beam, whatever. They just need to know it comes as one piece, one assembly or one equipment. Okay, simplify and then reference it and send it over to Revit. Okay, so there's also a thing called LOD, level of details, where of course in Inventor our target is to make sure it's one-to-one. So every bolt, screw and nut is in. Okay, but in Revit different, we need to simplify it. So from Inventor, we can save it as directly as RFA. Sorry, this one is beam extended as RFA. Okay, this is Revit family, IFC or Autodesk Exchange file. We can also now export or save as to .rbt, where Revit can directly open our Inventor models. Doesn't matter if originally your equipment comes from any software, as long as you open it in Inventor, you localize it in Inventor, and then you can make it Revit or BIM format. So you can treat Inventor as a medium to be in the workflow, or let's say if you use Inventor to design your equipment, it's much better. Okay, why is it much better? Later we'll see more. Okay. Okay, simplify and publish BIM content. Okay. So example, this is our equipment. So in Inventor, so we just simplify the things. So we do not need to know how many panel is there. Okay, we simplify it to make sure that it's like just a box or envelope. We can just hide everything. So in Revit, they do not need to know details. We just got the shapes and also the inlet and outlet. So in this case, the inlet and outlet of the pipes. The pipes connectors. Okay, we specified where is the pipe connectors, the diameters, and the system type, so that this is all later will be shown in Revit. Okay. So let's say this is unit return. Okay. And then of course specifies UCS as the origins, and then we can just select the classification. Of course, you can skip this. But if you want to add more details, you can also add more details here. Okay. In the case where you don't want to share too much information, you can just straight away skip this and just export. So this is export to the file format RFA. The RFA is Revit family. Okay, so it's exporting. Okay, so this is okay. Now in Revit, so this is Revit. So let's say after we inserted the equipment just now, right? So all this connector is usable. From Revit, we can insert pipes and everything from Revit. So it's not just one dummy shapes there. It's an equipment that we can use in Revit. Okay. So that is one way where we send over our file as a RFA or Revit family. Okay, so we can also use Revit to Inventor data exchange, where we can use or send over our Revit model, okay, the building model, over the cloud. You don't have to save it locally, put in a thumb drive and pass over. You can send it over the cloud. Okay, example, I believe most of you are in this blue box over here. Okay, so this is the thing that I explained earlier. So let's say from Revit, they just need to define the area of interest. You know, a building is very big, right? So you don't have to specify the whole building. You just specify the area of interest. Let's say I want to put or insert my lift inside this building. I do not need the porch. Okay, the room. Okay, so we can just specify the area of interest and we share that area of interest only. Okay, and then comes into the Inventor, we link it, insert our content, update, simplify, all this, and then we send it over back, all through the cloud. Okay, here is an example. This is called Revit Data Exchange, started in 2023. So from Revit, I can just specify the area of interest, save it to cloud, and then specify the area of interest. This is all in cloud. Okay, let's say we specify, this is a factory, by the way. So the area of interest is this. Okay, save it to the cloud, save it to the location that we can collaborate. So now from Inventor, I open it up also from cloud. This is the area of interest that has been assigned to me. Okay, so I can open it up. So it's reported in. So this inside Inventor, I just add my equipment or my machines into the structures. Okay, so in case there are some changes in the Revit model, those who use Revit and who use Inventor to insert their component also will get updated. Okay, so you will reduce a lot of like changes, updates, last minute changes and updates. Okay, so challenges in this building design is architect want to design the building all very nice, canggih-canggih, right? You know Malaysia have many box building, right? Just recently ada banyak building yang sengih-sengih, got shapes and shape, right? Okay, so architect can design all that fancy stuff, but can it be manufactured? So that's another thing. Okay. So what we want to do is we want to, let's say we go towards productization. So we create all our building equipments, building products, define what is the products. Okay. Design product with certainty. Okay, this one just okay. So let's say this product designer is here, product engineer. Okay, architect, general contractor, fabricator is all here. So we can supply across all the process. So inventor is all here. We supply to all the other life cycle. Okay. So, anyone familiar with design automations in Inventor? Or iLogic in Inventor? No, not sure. Okay. So, you know how equipments have specification, right? Variations of size and specs. Okay, so you can automate that. You design one equipment, but you can change the variations from a button away, and it will auto updates. So that is design automation in Inventor. Okay, so if previously what I showed previously is a static model where you design like this, you send it like this, but now we can also send it over as automations designed with multiple sizes. Okay. So customizable product family, this is from Inventor. Okay, and then go over to Revit family. Okay. So from engineer, from product engineer. So we publish, and then the building designer will take our models, and then they'll start their building models and start build up. So it's like we are sending in a catalog for them to choose. Okay, so from product engineer, so let's say this is from Inventor side. So we just create our model as usual, define beam content, make sure all the rules of sizes and publish it. Okay, this is where Revit will open up or use our equipments. Okay, this is where the productions will open up the completed so-called approved projects and start to manufacture. So Autodesk Inform Design. Okay. Example, this is in Inventor. So let's say Inventor, we want to create parametric model. You know, Inventor comes with all this parameter. So all these parameter you can control. Okay. You can control and you can make use of this parameter by creating in a form. Okay. A rules. So let's say I change the width to 4,500, it automatically update. Okay. Change the depth. Okay, it automatically update. Okay, we can set many more things in Inventor. So from there, all the drawings, all the details will also get updated. Okay, so that is the design automation part. So we want to send over this automated model into Revit. So let's say the Revit can change in size themselves. So the process is pretty much almost similar, where we need to specify where is the connector, where is the what is the type of models. Okay. Okay, what is the parameter we want to control or we want to send over to Revit? Maybe we just want to let the architect to change width and length only. Okay, we can control whatever we share to them, and we can also share the drawing in case they need the drawings. Okay, this is all the parameter. Okay, we just give them width and depth only. You can only change width and depth. Okay, so this is so-called like a graphical rules lah. Okay, so let's say example minimum depth is 1,000, and maximum depth we can specify 5,000. So they cannot go over these rules. Okay, so this is just like rules like width, what is the minimum, what is the maximum. So they cannot suka-suka change to something else. Okay, and then the rest is just like logic rules. So let's say that let's say they try to go over the value. So we set some rule depth cannot exceed width. Let's say they want to make sure that they want to make the depth longer than the width. So it will appear an error lah. So we see. Okay, and then we just send it over. So output is where we send it over to BIM. Okay. And also PDF files. Okay, bill of materials. Do you want to share bill of material to them? What is the neutral format we want to share together in this package? So publish and send over, just put some names, put in some locations. You can specify our own folder structure. And yeah, we send it over to the architects or the Revit modeler. So this is one after we publish. So they just, next from the Revit, they just open it up and then they just reuse it. So let's say in Revit, so they just open up Revit and then they insert the components or the equipments that we sent over just now. So let's say it's a balcony just. Okay, so it's a modular frame. So this modular frame, send it over and place it into Revit. Okay. So this comes with size where also we have some balconies. Now I want to insert the balcony we just created. So customize, so we can control all these values. Previously, we send one static model. Now we can send models with sizes. Okay, depending on how is the project coordinations. Sometimes you just need to send static model. Sometimes you just want to make sure that your the receiver have multiple options. Okay, so I just add in the balcony just now we just created. Okay, so it's there. And if let's say we change in size again, it will also update it. Okay, edit. So let's say we edit the size 4,000 width. Okay. Okay, changes already successfully applied. So this is previously done in Inventor, yeah? And now Revit can use it as variations, not just a static dummy models. Okay. Okay, and then the production engineer will just generate the build, open the project and just create and just use the bill of materials and the drawings to start fabrications. So they can view it over the browser, and then they can view it like this, and they can also download or generate the output from the cloud. So you can download drawings if they need. So they do not even need to open up in AutoCAD. So they can just download from here. They can view and download from here and use AutoCAD to view and to start with productions. So this is a bit towards project management or data management as well. Everything is centralized in the cloud. Okay. So from Inventor, we're connecting. Okay, to this one is manufacturing uniform designs. Okay, to building model, building design. Okay, with too much detail. So everything is across over the whole life cycle. Okay, so next comes into part is the collaborations or coordinations of files. So you know, in a project you work with multiple files. Okay, not just AutoCAD file, not just Inventor files. You probably people are sending you many file formats. So if you have Navisworks managed, you can do all this where you can, you know how 3D model file is a bit heavy, right? Sometimes. So Navisworks can help to make it lighter, easier for review purpose. Okay, you can also do clash detections where you can run the whole project to automatically search for clashes, and also project management for the construction simulation or project simulations. Also for design review. Okay, this Navisworks Manage comes with product design and manufacturing collection. So if you have product design and manufacturing collection, you already have this. This is a sample of say okay, sample in Navisworks. So Navisworks, let's say this is from Plant 3D. Okay, and then in the Plant 3D later we can add more like Revit models or maybe Inventor models into here. So with Navisworks Manage, we can measure. Okay, we can review. This is the lighter versions. Okay, we can put in remarks for collaboration and coordinations. We can also do clash detections. So let's say I run clash detection for these files. Okay, tolerance of detections. Okay, it will auto detect clashes. Okay, so let's say we can see that where's the clashes, we make amendment to the clashes, and then let's say we can also create like favorite view over here. So where we can like presenting, we show to customer, so the video output, so that the output is not so good. Okay, we can, let's say this one, we detect the clashes. So Navisworks will show you where is the clash, and then you go to it, your design software, Plant 3D or Inventor or what are the application you're using to make the amendment. Navisworks will not make the changes for you. It will show you where is the clashes you need to change in your design software. We can also do like a 3D walkthrough and also a timeliner, a project timeliner. So from when the project starts to when the project ends. So the projector making it a bit jagged, but we can run the project based on a timeliner. So you can also import from Primavera or Microsoft projects. So you can see how the projects timeline. So you can estimate how long the project takes. To show simulation, how long the project takes, and so on. So that is Navisworks. So apart from that, you can also use Navisworks to collaborate. Okay, so from Inventor, let's say just go to Navisworks and then you can just use Autodesk rendering from Navisworks. So here you can also again take your phone and try to scan. So we try to do some collaborate, some hands-on activity. Okay, you can scan here, so you will see some of the examples that has been shared and that I already shared on the cloud. So if you attended my session previously, you probably have seen this. If this is your first time, you probably want to try. Just use your phone to scan the QR code. So all three QR code has different locations. Okay, so you can view it from like Google, or you can at the bottom have like a arrow, right? 4 arrow. You can click on that and you can use your finger to navigate. Okay, so let's say you already scanned. So this is all the three locations. So imagine after you putting in your equipments into a factory or a buildings, right? So you want to show, instead of a normal image and a normal video, you can use this. If you have Autodesk PDMC, means you already have this. If you have Navisworks Manage, means you already have this. You can see, right? This is on a bigger scale. So you can also do this for product. Let's say you don't want to show the area, you can also use Fusions or Navisworks Manage to focus on your product only. Maybe the angle, different angle of your products. Okay, so you are looking into something like this, right? You can separate. Of course, it's not like a real VR where you walk through, but it can go 360. Okay, you can create a scene and just render it to the cloud, and it's even a rendered cloud. Okay. So BIM integrations and interoperability are so some challenges where we want to they want to influence product specifications. This is where BIM content comes in. So we send in our equipment as a BIM content. Okay, design coordination for workflow interoperability. So construction management for on-site coordination and installation with the resource also. Okay, supply product data in BIM format. We simplify with our inventor. Okay, we produce accurate 3D BIM project or equipments. We can integrate metadata into our inventor and send it over as BIM formats. Okay, so we are at the end of my sessions. Any questions? Everyone still okay? Too much? Too much information? All right, so in case that now maybe you are not in the industry or in a work scope that sending over or work with BIM, but maybe after this or maybe in the future, you will. So this is a good exposure for you. So you know that the solution is already there because this is where Malaysia industry trend is moving. Okay. So a lot of companies has moving towards this because their end goal is to make sure their product can be supplied into buildings. How to make it easier for the building architect or building designer to consume your products. Okay, some of the project tenders also has been specified. Everything need to be in BIM friendly format, something like that. Okay, so this is a good medium where you use inventor to bring in all your equipments, all your product from any other third-party software or any other software, put it in inventor, make it a BIM format. And you can even make it more smart with variations and so on. Okay. And you can also work internally with an inventor and also your other third-party formats, other brands. So you don't have to switch everything over. You can work side by side. Okay, depending on how you plan your team and departments. So, okay. Okay. All right. I think we quite ready.
Okay, we would like to open the floor again for any questions. If you do have any questions to the speakers today, we will have a small gift for you. You can ask questions from the first session, the second session, and the session presented just now. So anyone?